Good morning, students. We are in recurrence relations. Today we are going to solve recurrence relation 2. We are in Laguerre's recurrence relations. Today we are going to solve recurrence relation 2. Recurrence relation 2 is given by x ln dash of x is equal to n ln of x minus n ln minus 1 of x. So in Laguerre's recurrence relation 2, what we have to prove? We have to show x into ln dash of x is equal to n ln of x minus n ln minus 1 of x. So to prove this recurrence relation 2, we are going to consider generating function of Laguerre polynomial. We are going to consider generating function of Laguerre polynomial. So coming to solution, first we are going to consider generating function. Generating function of Laguerre polynomial. So generating function of Laguerre polynomial is given by what? E power minus xz by 1 minus z by 1 minus z. So it is given by e power minus xz by 1 minus z by 1 minus z is equal to summation n is equal to 0 to infinity ln of x into z power n. So generating function of Laguerre polynomial is given by e power minus xz by 1 minus z ma. It's not 2. 1 minus z by 1 minus z is equal to summation n is equal to 0 to infinity ln of x into z power n. Consider this as equation number 1. Okay. Now we are going to differentiate equation 1 with respect to x. We are going to differentiate this equation with respect to x. So write down a small sentence. Differentiating equation 1 with respect to x. So what you will get here? 1 by, I am considering it as this term as 1 by 1 minus z into exponential of minus xz by 1 minus z. So the differentiation with respect to z is minus, with respect to x is minus z by 1 minus z ma. Okay, minus z by 1 minus z is equal to summation n is equal to 0 to infinity. Here d by dx of ln of x can be written as ln dash of x. Here dash represents the differentiation for Laguerre polynomial into z power n. Now I am going to write this term. Okay. Now what I am going to do is, here minus z I am bringing as an initial term. So minus z. Okay. Into e power minus xz by 1 minus z. You take whole term. Okay. Into, now here 1 by z is there. So is this 1 minus z sent to the RHS side. So as it is in division form, if you send to the RHS side, it comes to multiplication form. So is equal to, I am bringing this term to the RHS side. So you can write it as 1 minus z. Okay, summation n is equal to 0 to infinity ln dash of x into z power n. Now here, now taking the use of equation 1. So you write minus z like that only. Again e power minus xz by 1 minus z by 1 minus z can be written as summation n is equal to 0 to infinity ln of x into z power n. So using equation 1, using equation 1. So how can I write this by using this term? How can you write this term? Minus z like that only. The value of this, that means this term can be written as summation n is equal to 0 to infinity ln of x into z power n is equal to. Now what we are going to do is 1 minus z is multiplication with this summation term. So once you multiply 1 into this summation term, you will get summation term only, minus z into this summation term. So same thing I am going to do now. So 1 into this summation term only. So summation n is equal to 0 to infinity ln dash of x into z power n. Next, minus z summation n is equal to 0 to infinity ln dash of x into z power n. Okay. Now here you are clearly observing. Here z term is there. Here also z term is there. Here only one term. Here also two z terms are there. So you all know that as bases are same, powers can be added. So same thing I am going to do for the next step. Now minus summation n is equal to 0 to infinity ln of x. Now z and z power n. Here what is the power of z1? So n plus 1 is equal to summation n is equal to 0 to infinity ln dash of x, okay, into z power n. Here bases are same, powers are added. So summation n is equal to 0 to infinity ln dash of x. Here z power n, the power of z is 1. So z power n plus 1 you will get. Now for this equation, now equating coefficient of z power n on both sides. So here you observe, here there is no z power nth term, okay, but z power n plus 1th term is there. So in order to make it as z power n, in place of n you keep n minus 1. If n plus 1 is there, wherever n is there, you keep n minus 1. Here also no need to change because z power n coefficient is ln dash of x. Here also z power n plus 1 is there. So wherever n is there, you keep n minus 1. So that we can equate the z power n coefficient for this equation. Now equating the coefficients of z power n on both sides. So what will get here, minus summation n is equal to 0 to infinity. Now here ln is there. So in place of n minus 1, n minus 1 you have to write is equal to summation n is equal to 0 to infinity. Z power n coefficient is ln dash of x. Okay. Next here also minus summation n is equal to 0. If you consider summation, or if you won't consider the summation also, no problem. Okay. Anyhow, we are going to remove for the next step. Now z power n plus 1 is there. So wherever n is there, you write down n minus 1. So L n minus 1 dash of x. Okay, or simply you can write it as. Now I am going to remove the summations. So what you will get? By removing summations, what you will get? Minus L n minus 1 of x is equal to ln dash of x minus L n minus 1 dash of x. We got this equation. Now consider this as equation number 2. Okay, and rearranging, then we can term it as equation 2. Now from this expression or equation, we are going to find the ln dash of x value. So if you want to find ln dash of x value, what we have to do is send this term to this side. So what you will get here, as it is a minus term, if you bring to the LHS side it becomes plus term. So Ln minus 1 dash of x minus Ln minus 1 of x. Okay. So consider this as equation number 2. This as equation number 2. Now again we are going to consider recurrence relation 1. We are going to consider recurrence relation 1. Now we are going to consider recurrence relation 1 of Lagrange polynomial. Recurrence relation 1 of Lagrange polynomial. So what is recurrence relation of Lagrange polynomial? It is given by n plus 1 into Ln plus 1 of x is equal to, okay, n plus 1 into Ln plus 1 of x is equal to 2n plus 1 minus x into Ln of x minus Ln minus 1 of x. So this is the recurrence relation 1. Consider now, after equation 2 we have considered the recurrence relation 1. Now for this recurrence relation 1 we are going to apply the differentiation with respect to x. Differentiating equation, differentiating above equation with respect to x. So what you will get more? N plus 1 d by dx of, okay, Ln plus 1 of x is nothing but Ln plus 1 dash of x you will get, okay. So applying differentiation to this equation we will get n plus 1 like that only. Differentiation for this term become, you can write it as, that means d by dx of Ln plus 1 of x can be written as Ln plus 1 dash of x. Here dash represents the differentiation of this term is equal to 2n plus 1 minus x. Now same thing, the differentiation of this term can be written as Ln dash of x, again with respect to x, no. So what you will get? Here differentiation of this is 2n plus 1 minus x Ln dash of x minus x Ln dash of x. Next minus the differentiation of this term, what will get? N Ln minus 1 dash of x. Now consider this as equation number 3. Okay, consider this as equation number 3. Now replacing n by n plus 1 in equation 2. So here equation 2 is there, no? So wherever n is there, that n is replaced by n plus 1. Replacing n by n plus 1 in equation 2. Replacing n by n plus 1 in equation 2 more. So wherever n is there, you keep n plus 1. So consider this one L. Here n is there. So n plus 1 dash of x. Next is equal to L. N plus 1 minus 1 dash of x. Next minus L. N plus 1 minus 1 of x. So just I have replaced n by n plus 1. So here L n plus 1 dash of x you will get. Here minus 1 plus 1 gets cancelled. You will get Ln dash of x minus, here what is here, minus 1 plus 1 gets cancelled, minus Ln of x. Okay, now consider this as equation number 4. Okay, this as equation number 4. Already 3, then this is 4. Now we are going to again rearrange the terms in equation 2. Rearranging the terms in equation 2. So from I am going to rearrange the terms in equation 2. Now I am interested in finding Ln minus 1 dash of x. So Ln minus 1 dash of x can be written as Ln dash of x plus Ln minus 1 of x. Okay, just I have sent this term to LHS, so it becomes plus term. Consider this as equation number 5. Now we got Ln minus 1 dash of x. Okay. Now substituting equation 4 and 5 in equation number 3 more. Substituting equation 4 and 5 in equation 3. We are going to substitute equation 4 and 5 in equation number 3. Now we are going to substitute equation 4 and 5 in equation number 3. So once you look at equation 3, okay, n plus 1 of n plus 1 dash of x is n plus 1 like that only, ma. What is n plus 1 dash of x value? Okay, this term. So I have written, I am going to write ln dash of x minus ln of x. Next is equal to 2n plus 1 minus x. Like that only. Ln of x also like that only. Ln dash of x like that only. Okay, minus x ln dash of x like that only. Next minus n, I have written like that only. What is ln minus 1 dash of x? This term. Ln dash of x plus ln minus 1 of x. Just I have substituted equation 4 and 5 in equation number 3. Then we got this equation. Now you multiply this n plus 1 with this term and with this term. So what you will get? N plus 1 into ln dash of x. Next minus n plus 1 ln of x is equal to, now 2n plus 1 minus x I have kept like that only. 2n plus 1 minus x I have kept like that only. Ln dash of x minus x ln dash of x. Next you multiply n with this term and this term. N ln dash of x plus n ln minus 1 of x. Yes, by multiplying the terms we got this equation. Now from this equation, wherever from these two terms, here ln dash is there, here also ln dash is there, here also ln dash is there. Okay. Now you take ln dash of x as common term. Okay. Ln dash of x as common term. Here while differentiating recurrence relation 1, so the differentiation of this 1 is 2n plus 1 minus x ln dash of x only. Okay, here you won't get this term. Okay, so here because the differentiation of with respect to x, no, so 2n plus 1 minus 1 2n plus 1 minus x, differentiation of this we have written as ln dash of x, that's it. Okay, now in this what we are going to do is you keep this term like that only. N plus 1 ln dash of x minus n plus 1 ln of x. Here I am going to consider 2n plus 1 as one term and minus x as another term. So 2n plus 1 into ln dash of x. Next minus x ln dash of x. Just I have multiplied 2n plus 1 into this term minus x into this term. Okay. Next here minus term, no? So minus of this term. So by multiplying you will get minus, and here also minus term. These two terms becomes minus. So minus L minus n ln dash of x minus n ln minus 1 of x now. Now here what we are going to do is accept n plus 1 minus n plus 1 ln of x is there, no? You send to the RHS term. Okay, you send to RHS side and bringing this term and this term to LHS side. So initially I am going to write the first one, that is n plus 1 of ln dash of x minus n plus, and as I have said that this term will be sent to that side. So I am bringing this term to the LHS. So as it is a plus term, it becomes minus term minus 2n plus 1 ln dash of x. Because why we are bringing? Because in order to take ln dash of x as common, and as it is a plus term you will get plus, as it is a minus term, if you bring to the LHS it becomes plus term. So x ln dash of x. Okay, and as it is a minus term it becomes plus term. So ln dash of x is equal to, I am bringing this term to RHS now. So as it is a minus term it becomes plus term in the RHS side. So plus n plus 1 ln of x minus this ln minus 1 of x. Yes, by rearranging the terms in this equation we got this equation. Now you take ln dash of x as common. So what you will get? Ln dash of x, if you take common, n plus 1. Next minus 2n plus 1 is nothing but minus 2n minus 1. Otherwise write down like that. Next plus x plus n. Yes, as I have to, ln dash of x is common. Then the remaining terms in LHS, RHS is n plus 1 into ln of x minus n n minus 1 of x. Okay. Now here 2n minus 2n gets cancelled and minus 1 here. Okay, I will write one more step. Ln dash of x n plus 1 like that only, minus 2n minus 1 plus x plus n is equal to n plus 1 into ln of x minus n ln minus 1 of x. Now here plus 1 minus 1 gets cancelled. Here n plus n 2n minus 2n gets cancelled. Only remaining x is there. So x ln dash of x is equal to what you got? N plus 1 ln of x minus n ln minus 1 of x we got. So this is a required recurrence relation 2. Whereas I have said x ln dash of x is equal to n ln of x minus n ln minus 1 of x, as I have said, but it is n plus 1. Okay, here the required equation is n plus 1 of ln of x minus n ln minus 1 of x. So this is the required relation 2. Okay, in the statement I have said that it is n. Okay, it's not n, it is n plus 1 into ln of x. So this is Lagrange's recurrence relation 2. Once again I am repeating, in recurrence relation 2 we have considered generating function. So first we have considered the generating function. For that function we have differentiated. Then again we have considered the recurrence relation 1 by taking use of that, and by this we have finally concluded x ln dash of x is equal to n plus 1 into ln of x minus n n minus 1 of x. Next we are going to know about recurrence relation 3. Next we are going to know about recurrence relation 3. In recurrence relation 3, we have to prove ln dash of x is equal to minus summation r is equal to 0 to n minus 1 LR of x. So what is recurrence relation 3? ln dash of x is equal to minus summation r is equal to 0 to n minus 1 LR of x. Now the generating function we are going to consider. The generating function of Lagrange polynomial is what? E power. Okay. Generating function of Lagrange polynomial. Function of Lagrange polynomial is given by e power minus xz by 1 minus z by 1 minus z is equal to summation n is equal to 0 to infinity ln of x into z power n. Consider this as equation number 1. Now we are going to differentiate. Now before differentiation you consider RHS as LHS and LHS as RHS. So we are going to differentiating equation 1 with respect to x. So what you will get now? As I have said that we are going to consider RHS as LHS. So summation n is equal to 0 to infinity ln dash of x into z power n is equal to, with respect to x now, so 1 by z, or you can write e power minus xz by 1 minus z by 1 by e power minus xz by 1 minus z by 1 minus z. Otherwise you can write it as 1 by 1 minus z into e power minus xz by 1 minus z. Differentiation with respect to x now, so again you will get minus z by 1 minus z you will get. Now send this term to LHS side. So LHS side, what you will get here? Now this term remain like that only, that is summation n is equal to 0 to infinity ln dash of x into z power n, like that only ma. Now this whole term is in the form of n is equal to 0 to infinity. If you consider the limits r is equal to 0 to infinity, you can write it as LR of x into z power r. So same thing I am going to do here. So again this by using equation 1, okay, in place of n we are going to consider r. So summation r is equal to 0 to infinity LR of x into z power r. Here minus z I have kept like that only. I am bringing 1 minus z to the to the numerator. So what you will get here? 1 minus z whole power minus 1 you will get. Now summation n is equal to 0 to infinity ln dash of x into z power n is equal to, you keep this term like that only, that is summation r is equal to 0 to infinity LR of x into z power r. Now I am going to expand this 1 minus 1 minus z whole power minus 1 term. It is in the form of 1 minus x whole power minus 1. So it can be written as 1 plus z square and so on. So here minus z I am keeping like that only. 1 minus z whole power minus 1 can be written as 1 plus z square, z cube and so on, plus z power s and so on. Now multiply these terms with this.